Hey everyone, welcome back to our statistics class notes. We're now section 9.2, talking about the central limit theorem for sample means. And right now we're understanding a little bit about how to see how this all works. So we're trying to visualize how this central limit theorem works. So it's page 138. So example 159, visualizing distributions of the sample mean. This figure right here below shows the distribution of in-state tuition and fees for all two-year colleges in the United States for the 2012 to 2013 academic year. Okay. Now, hopefully, if you're looking at this and you would say, well, if I asked you to describe the shape of it, how would you describe it? Looks to be multimodal and probably skewed right? So it's certainly not a normal distribution, that's for sure. It's not a bell-shaped curve. So yes, we would describe its shape as skewed right and multimodal. Thus, it is certainly not anywhere near a bell-shaped curve. In other words, a normal distribution. Now, the figures below show the distribution of the sample mean for samples of size 30 and size 90 drawn from this skewed multimodal distribution. So that's not a normal population at all. However, notice that if I draw samples, so I draw, multiple samples of size 30 and I plot all their means, then I get pretty much an approximately normal distribution. If I increase the sample size to 90, again, I get pretty much an approximately normal distribution, and my standard error is smaller, right? The horizontal spread here is much smaller. The standard deviation of this distribution is much smaller, which is the standard error. How are we doing? Does that make sense? So we note here that the shape of each of these is approximately normal. And the standard error decreases as the sample size increases. So this is much more spread out horizontally. This is less spread out because the sample size is larger.